All right, ladies and gentlemen, we are talking about lesson 1212 today. We are going to be helping you guys with your probability unit, and it's important that you guys take these notes down. The good news is that you can pause, rewind, rewatch, whatever it is you need to rewatch to help you understand this information. There are a lot of vocabulary words, so make sure you get them written down, and you can double check them with your textbook as well to make sure that everything is understood clearly before we take a test on this stuff. So write down your essential questions and these two vocabulary words as we're getting ready to start 12.2. So compound events and independent events are certain types of events that will happen in our probability unit. Now, a compound event is a event that consists of two or more simple events. So like the probability of you rolling a 3 on a number cube, and then maybe to compound that would be to draw a red card out of a deck of cards. So those are two different simple events that we're compounding together. Now, independent events is when the outcome of one event does not affect the outcome of another. So it's the probability of one thing and the probability of another thing, but they don't have any relationship to each other, like my example with the cube and the deck of cards. Now, if we're looking for finding the probability of those things, it's the probability of one event times the probability of another event. So that's how we're going to figure these things out. It's similar to the fundamental counting principle. So make sure you have that stuff written down. So here's our first example. The two spinners shown below are spun. What is the probability that both show a number that is greater than 2? So if we look at this, we have how many numbers are greater than 2? 3 and 4. So 2 out of the 4 are greater than 2, and on this one, 2 out of the 4 are greater than 2. So if we're going to find the probability of those things, we're going to multiply 2/4 times 2/4 to get ourselves a 4/16, which is the same as 1/4. So there's a 1/4 chance that we're going to be able to do this. So let's go ahead and try it to see what happens. There's a 1/4 chance that both numbers are greater than 2. Oh boy, so we had a 1 and 4. Let's do that 4 times, see what happens. So we had a 3 and a 4. Oh, this time it's not going to work. Didn't work. Here's our third attempt. It worked, didn't work. And it worked and didn't work. So in 4 attempts, one of them was true, that both numbers were greater than 2. So that's kind of cool that it actually worked the way that we thought it would. All right, so again, folks, in our probability, this would be the probability of a number that is greater than 2. And we just found out that was 2/4 times 2/4, which got our answer of 1/4. All right, let's go on to our next one. Example 2, a pink number cube and a green number cube are rolled. The faces of both cubes are numbered from 1 to 6. What is the probability of rolling a 3 on the pink number cube and rolling a 3 or less on the green number cube? All right, so if we're looking at this pink and green number cubes, the faces are 1 through 6. So what is the probability of rolling a 3 on the pink one? Well, the probability of rolling a 3 would be a 1 out of the 6 sides. And on the green one, the probability of rolling a 3 or less, well, there's, out of all the choices, a 3, 4, 5, or 6, 3, 2, and 1 are possible. So that's a 3 out of 6. So our question is asking us is, what is the probability of rolling a 3 on the pink, and, very important words, and rolling a 3 or less on the green? So we have to multiply 1/6 and the 3/6 together because we're multiplying there are two compound events. So 1/6 times 3/6 is getting us to the answer of 3/36, which simplifies to 1/12. So 1 out of 12 times of us rolling this, we should get a 3 and a number less than 3 or less. Haven't gotten there yet. 3 and 3 or less. So that happened right there. That was only the 4th try. So as you guys can see, this is something that we can check with our own experiments, but this is the math that we need to be able to do. You find the probability of each individual event and multiply them together. Now there are other things called, let's scroll down here, called dependent events. Now the example that we just skipped over was the exact same thing, but without being pink and green, I had them labeled as red and white. So there's this next vocabulary word of dependent events. If 2 events M and N are dependent, then the probability of both events occurring is the product of the probability of M followed by the probability of N after M happens. So that's like if I'm digging through my drawer of socks and I need to get out a red sock and a white sock. After I've pulled one out, there's no longer maybe 10 socks. Now there's only 9 socks left over. So the probability on my next draw is going to be affected by the first draw. And that's what the dependent event is talking about. Things are dependent upon what happened first. So here's an example with socks. Gotta love that. There are 4 red socks, 8 yellow, and 6 blue. That's a total of 18 socks. Okay? 1 sock is selected and it is not replaced. Find the probability of reaching into the drawer without looking and picking 2 blue socks. So the first one of getting a blue on draw number 1 is a 6 out of 18 chance, because there are 6 blue socks out of 18 total. On my second pick, if I have a blue one, now there's only 5 out of 17. So I'm going to multiply these two together to get ourselves what the probability is. And hopefully you guys can do that very quickly. I'm going to grab my calculator. It's actually my cell phone. And I'm going to multiply these fractions together. So 6 18ths times 5 17ths. So I get the fraction of 30/306. And I'm going to want to simplify that. Let's see if I can divide by 2. Be 153 over 15. I think I can divide by 3 again. So that becomes a 15 divided by 3 is a 5, and at 153 divided by 3 is a 51. So I end up with a 5 out of 51 chance that I'm going to pick 2 blue socks. And you guys just saw my thinking on that whole process. So again, the probability, something fairly easy for us to solve. All right, folks, make sure you write down a summary of our answer to the essential question. And I'm checking out. Peace.